Okay, last one for computational logic for the minute. We're going to look at truth tables in this one. I'm going to stay out of full screen because I'm going to have to do some typing in a minute. So, truth tables. What these tell you is every possible combination that can go into and out of a logic gate that's in front of you. Okay, so if you look at the NOT gate, this is its truth table. It's only got one input, a NOT gate, so I can either have a 0 or a 1. The output would be the opposite. If I look at an AND gate, I've got two inputs, A and B. If 0 and 0 arrives, 0 out. 0 and 1, 0 out. 1 and 0, 0 out. The only time I will ever see a 1 come out of an AND gate is if I've got a 1 and a 1. Okay? The OR gate. Okay? 0 and 0 makes a 0. 0 and a 1 will make a 1 because I need either a 1 in this column or a 1 in this column or a 1 in both columns to give you 1s. So 1 and 0, 1, 1, 1, 1. Okay? They just show you the truth about what will come out of a gate depending on what you've inputted into it. Now in your exam you'll be given a bigger one than that. This is a medium one. Alright? It's just a simple logic gate diagram or a logic statement, and you've been asked to complete its truth table. So you put in an extra column. Alright, because you need to know what the output is of this in order to work out what comes out of it at the end. That, just there, is how you write that. That's what that is. So, B, not B, so that'll be 1, 0, 0, 1. Alright? So, we've just done the opposite of whatever's in this column. So now this column is A and not B column. So I can ignore this column altogether now. Get rid of it. I'm looking at these two columns as an AND gate. Is that a 1 and a 1? No. Is that a 1 and a 1? No. Is that a 1 and a 1? No. Is that a 1 and a 1? Yes. That's your truth table for that diagram. They might give you extra gates and a table as big as this. Okay? So I'm going to start again. I'm going to do the not B's. Okay? Not B, 1, 1, 0, 0. A and not B. Well, I don't need that anymore. A and not B. So that's 0, 0, 0, 0. Missed one. There. 1. I knew there was a 1 there somewhere. Right. A and not B or C. Don't need that. Don't need that. I'm looking at this and this. So I need that column or that column to be a 1. Well, it's there. I can see it. 1, 0, 0, 0. The reason why there's 4 more rows here is because you've got to do exactly the same again if C was a 1, because that's the other option we've not done yet. Every possible eventuality of this combination has to be done. So we'll rewrite all this. 0, 1, 1, 0, 0, 0, 1, 1 makes 1, 1, 0, 0, 0, 1, 0, 0. These all change to 1s. 1, 1, 1, 1. So I need that or that to be a 1. All of them. 1, 2, 3, 4, because all those are 1s. And it's very simply just there, it says or C. So as long as C is turned on, they'll all be 1s. The last thing I need to show you, because obviously we've done truth tables, logic diagrams, everything else like that, is that in the exam, they may write these statements slightly different. Okay? This is why I've done 3 different videos, because it's a lot to take in, and if you just do it step by step, it's fine. There. In your exam, they may write down A and B by writing that, which is really annoying, to be honest. And the only way I've come up to remember it is A and, so an and starts with the letter A, that is the symbol that looks most like an A. A and B. A or B. And the funny little squiggly one, because those gates look nothing like that gate, not A. And just to give you another example, that is what it would look like. Now, I am fully aware that looks ridiculous. And in an exam, you may be asked to tell me exactly what that means. All right? It may be that they give you that statement or one similar and say, draw the diagram. Well, you get marks for doing that bit, doing that bit, doing that bit, and labelling correctly. Okay? That could be a 4 marker altogether, just for looking at that. Well, if you can do or C and get that right, that's fine. If you could do not A and B, that's fine. If you could do an A and B gate, that's fine. This is a huge mark question, and so long as you can realise that that is an A and a B, and you can write an AND gate that does that, you would get a mark. All right, so you will definitely need to make note of those 3 other ways of drawing gates. Now, in one of the videos, I think it was the first one, I asked you to draw the gates. So if you want to just put those symbols next to it so that you know exactly what's going on, that would be better for you. Then you've got them all in the same place. All right, so we've done logic gates, logic circuits, we've now done logic statements and truth tables. All a truth table does is tell you the exact possible combinations that will come out of a gate, bearing in mind every input that's given to you. Now, I have seen in an exam before that what they've done is they've given you an AND gate and just omitted those 4 digits and said, finish off the table. And it was a case of you had to recognise that one of the inputs hadn't been put in, and could you follow it through and give the correct outputs. That was worth 4 marks. And if you're bearing in mind that's worth 4 marks, and something like that might be worth